In our last problem of the day, we want to find the length of a chain that goes around two sprockets for a bicycle. So, similar to the track problem, I've got several pieces to consider. To find the total length of the chain, I've got to just add all those pieces up. I'm going to start again with, if I see a straight piece, why not just include that right off the bat? So there's two 10-inch portions that will be straight, so 2 times 10. Now I want to look at the two portions that are on the curved sprockets. Okay, so the left smaller sprocket over here has a central angle of 160 degrees, and it's an arc. So I'm going to use my arc length formula of 160 degrees over 360 times the circumference. Circumference is 2 times pi times the radius, which is 4. I represented it here by R1. R2 is my other radius of the bigger circle, bigger sprocket. When I multiply that out, I get, I'm just going to put this rounded to the nearest thousandth because if I leave it in terms of pi, it gets a little ugly. So 11.170, I'm going to leave it as such. So usually we want to avoid that, but in this case it's pretty hard to, so I'm just going to leave it as is. And my final answer needs to be rounded to the nearest tenth anyways, so I should be okay. Next part, I want to find the larger arc length. So the larger arc length has a central angle of 185 degrees. So 185 over 360 times the circumference of that bigger circle is 2 times pi times 6. Again, I'm just going to multiply that out and get the answer to the nearest thousandth. So 19.373 inches. And now I've got all the pieces I need. Total length, I add 19.373 inches. I combine all, technically 4 of those parts, the 2 straightaways, the smaller curved portion, the larger curved portion, and I get a total chain length of 50 they asked me to round to the nearest tenth again, so 50.5 inches. And that's your final answer.